Okay, so on this problem right here, we've got real parts and imaginary parts. And when you've got a problem with real parts and imaginary parts, we're going to put together the parts that are the same. The parts that are the same. So if you'll notice on this, I'll write in yellow here, I've got 9 and 8. Yellow is hard to see. Let's do purple. We'll have 9 and 8. Those guys are real, okay? And then we've got in green, we've got plus 8i minus 9i. Those guys are imaginary. And so to just finish this problem off, you put the real parts together and the imaginary parts together. So if I have 9 plus 8, I've got 17. And for the imaginary parts, it's just like if I go, okay, what's 8x minus 9x? What is that? That is negative x. And so with my imaginary parts, I treat it the exact same way. If I've got 8 i's minus 9 i's, I've got plus negative I. Well, my answer then, in pretty math numbers, is going to be 17 minus I. And that's it. That's all you have to do. You're done. Okay, so section 6, 4.6, here's question number 25. And now we're going to multiply these guys together. So stick with what works. We know how to FOIL. So if we take our first terms, our outer terms, our inner terms, and our last terms. And so this is how we're going to do this. And this guy should be a negative 2, by the way. All right, so if you look at our first terms in red, our first terms in red will be negative 2 times negative 1. Okay, negative 2 times negative 1. Just like you FOIL with a regular binomial multiplication. And then the outer terms in green, so plus negative 2 times 4i. No problem, we can handle this. Plus the inner terms in blue, plus 5i times negative 1, plus the last terms. Let's see, the last terms. I drew a bad line here. My last terms should be these two guys right here. So plus my last terms, which is going to be 5i times 4i. And when I do this, the multiplication, keep it simple, like you've done forever. Don't change anything up. This is just going to be 2 minus 8i minus 5i. And then on this last guy, 5 times 4 is 20. I times I is I squared. It's no different than how you've multiplied stuff forever, okay? Except this. When you're working these problems out, I squared is equal to negative 1. You can't forget this little nugget of info. This is a big time nugget of info. Don't forget it. I squared equals negative 1. The reason you don't want to forget it is because right here we've got an I squared. That's a negative 1. So this is really 20 times negative 1. Okay? So what I've got is 2 minus 13i minus 20. And then put your real parts together with your real parts, put your imaginary parts together with your imaginary parts, and you end up with negative 18 minus 13i. So when you're working with these complex imaginary numbers, just FOIL these guys out like you FOILed your problems out in the past. Keep it with things that you know. Keep it simple as possible. Alright, so on this guy from section 6, question number 30, we want to eliminate I in the denominator. That's the whole goal here. Eliminate I in the denominator. Well, you've only got one piece down there in the denominator to begin with, and it's just a plain old 3i. So to get rid of I in the denominator, multiply the top and bottom of the fraction by the I. You don't need to worry about a conjugate on this one, okay? And then when you multiply the top, what you're what you end up with is negative 2I minus 5I squared. And on the bottom, you end up with 3I squared. And then run over here to the side and just remind yourself, hey, I squared equals negative 1 every single time. And since that's the case, what I'm going to have is negative 2I minus 5 times negative 1 over 3 times negative 1. So the final answer for this guy then is going to be negative 2I plus 5 over negative 6. And this is a good answer. And you know what? When you look, if you look it up somewhere else, it might say 5 minus 2I over 6. It might say 5 over 6 minus I over 3. All of these are the same thing. Okay? That's all there is to it. Okay. Bad math here. Actually, this should actually be negative 3 down here and negative 3 right here, not negative 6. I got all excited and carried away. So this could be then negative 5/3 plus 2/3 I. So these are the correct ways that you might see this problem. Okay, section 6, 4.6, and we're going to eliminate the complex number in the denominator. Okay, and this is question 32. So what I have to do is multiply by what's called a conjugate. A conjugate. So a conjugate is when I take the number 2 plus 3i, and I'm going to multiply by the conjugate. And the conjugate's kind of a tricky little term, but all it means is this. Whatever the sign is here, you change it to the opposite over here. So notice it's a plus, it becomes a plus. Sorry. Minus on the left, it becomes plus on the right. And if you will look, this fraction right here, this fraction reduces to 1. 2 plus 3i divided by 2 plus 3i is 1. So what I'm doing is multiplying by 1. Now here's the cool thing with the conjugate. On the bottom, the I term is going to go away. So all I have to do on bottom is multiply the first two guys and multiply the last two guys. That's all I have to do. And so what I'm going to end up with is 4 minus 9i squared. And don't forget, I squared is equal to negative 1. Don't forget that. That's important. And so basically, I don't have 4 minus 9i squared. I've got 4 plus 9 on the bottom. Okay? And then on the top, pay attention now. On the top, you're going to have to FOIL. You're going to have to FOIL. So first terms, 14. Okay? Outer terms, 21i. Inner terms, 8i. Last terms, 12i squared. Oh, wait. I squared, don't forget. I squared, what is I squared? I squared is negative 1. Okay? So what do I really have on top? Put the real parts with the real parts. Put the imaginary parts with the imaginary parts. Life will be good. So on the top, I actually have minus 12. So I've got 14 minus 12, 2. I've got 21 i's plus 8 i's. That's 29 i's. And put the denominator together, which is going to be 13. And then on the top, 2 plus 29i. And notice, what we want to do is eliminate the complex number on the bottom. Notice in your original problem, right here, I've got an I. In my new problem, I don't. I have a regular number. Okay? And that's what we're trying to do, and that's how the conjugate gets used. Okay? The conjugate is not a horrible, hard thing. You just change that middle sign to the opposite of what's originally given. On 33, we're going to use a conjugate. So we've got negative 1 minus 6i over 5 plus 9i. Okay, and what we want to do, the whole goal of this problem is to eliminate the I from the denominator. Like, we don't want the I in the denominator at all. And so to do that, we multiply by what's called a conjugate. So we're going to multiply the bottom guy by 5 minus 9i. Okay? And if I multiply by 5 minus 9i on the bottom, I'm going to multiply by 5 minus 9i on the top. This is called a conjugate. This is called a conjugate. And notice that the difference in the denominator between the normal problem and the conjugate is the sign in the middle. The numbers are the same. The numbers are the same. But notice right on the left-hand side, I've got a plus. On the right-hand side, I've got a minus. And that's the only difference. And then all I got to do from here is FOIL these guys out. Well, thanks a lot. I mean, that's a lot of math I have to do. Not happy about it. But on the bottom, the middle term will go away if you have it set up like this, where you've got the signs different. The middle term will go away, so all you'll need to do is multiply the first term, 5 times 5, and the last term, minus 81i squared. Okay? On the top, you'll have to FOIL the thing out like old school binomial crap, and it can be annoying, but it's not hard. It's first terms, it's outer terms, it's inner terms, it's last terms. Okay? And so what you're going to end up with is negative 5. There's your first terms. Your outer terms, plus 9i. Your inner terms, minus 30i. And your last terms, which are going to be 54i squared. Okay? So here's your problem. And then, things that are the same go together. Things that are not the same don't go together. Alright? So things that are the same go together. Well, look on the top. Things that are the same. The negative 5, and believe it or not, the negative 54. And why is this a negative 54? Because I squared is equal to negative 1. Don't forget this. This is an important thing. I squared equals negative 1. Every single time, no matter what. Alright? And so instead of adding 54i squared, I'm actually subtracting 54 here. So I've got negative 5 minus 54. What is that? Negative 59. And then 9i minus 30i minus 21i. On the bottom, the 81i squared, it's not 81i squared. It's going to be plus 81. So I have 25 plus 81, which is going to be what? Let's see, 25, 81, so 106. And this is a good answer. You can leave your answer right here. This is fine. Some books, if you look it up, might say 59 over 106 minus 21i over 106. Both of these are fine, totally acceptable, 100% perfect answers.